Welcome to another deep dive. We're tackling artificial intelligence, a modern approach this time. And wow, this textbook, it really goes deep.
Yeah, it's pretty comprehensive.
But hey, that's what we're here for, right? To dig into those dense chapters and pull out the good stuff.
Exactly. We'll be your AI tour guides.
So this book, it covers a ton of ground, right? From search algorithms and game playing,
Yeah,
all the way to like knowledge representation and even machine learning.
like a buffet of AI concepts.
A buffet. I like that. But before we dive into all that, I'm curious, like, how does this book even define intelligence in a machine? Can a computer really think, or is it just like mimicking thought?
That's the million-dollar question, right?
Yeah.
And the book tackles it head on. They talk about the Turing test, which, if a machine can chat so well that you can't tell it's not human, then bam, it's considered intelligent.
Right, right. The classic Turing test.
But the authors, they don't stop there. They dig deeper and explore how AI is shifting towards this idea of rational agents.
Rational agents. Okay, now I'm intrigued. What's that all about?
So instead of just focusing on whether a machine can trick you into thinking it's human, we're looking at how well it can achieve its goals. Like how efficiently can a self-driving car get you from point A to point B?
So it's less about like thinking like a human and more about acting strategically to reach a specific outcome.
Exactly.
Okay, I'm starting to get it.
And the book breaks down these agents into different types based on how complex they are. You've got your simple reflex agents. They just react to what's right in front of them, kind of like those bug zappers that go off when a fly gets too close.
Okay, so like a mindless machine, just following a basic set of rules. What about the more advanced types of agents?
Well, then you move up to model-based agents, which are a step up. They actually build a kind of internal map of their environment so they can make slightly more informed decisions.
So they're not just reacting to stimuli, but they're trying to predict what might happen next, like a chess player thinking a few moves ahead.
Exactly.
Okay, that's pretty cool.
And it gets even more complex. You've got goal-based agents that are actively working towards a specific goal, like getting that self-driving car to your destination. And then at the top, you have these utility-based agents.
Utility-based. Okay, lay that one on me.
These agents are all about maximizing their happiness or utility. Think of it like a financial advisor. Their goal isn't just to make money, but to get the best return for their client.
Wow, so these agents are like little happiness-seeking missiles. It's kind of mind-blowing that a machine could even be programmed to have something like happiness.
It really makes you think about what we even mean by intelligence, right?
Yeah, for sure.
And then the book goes on to explain how these agents actually solve problems. They use this idea of search, which is kind of like,
I'm picturing a little robot with magnifying glass desperately searching for clues.
not quite. But I love that image. Imagine it more like navigating a maze. The agent's trying to find the best path, the optimal sequence of actions to reach its goal.
Okay, so every decision the agent makes is like taking a step in this giant maze of possibilities.
Exactly. And the book talks about all these different search strategies, some super complex. There's breadth first search, where the agent checks out every path at a certain depth before moving on. It's systematic, but can be really time consuming.
So like meticulously checking every single street in a neighborhood before moving on to the next one. I can see how that would get tedious. What are some of the other strategies?
Well, there's depth first search, where the agent just dives deep into one path until it hits a dead end. It's more like taking a gamble, hoping you stumble upon the solution quickly.
Sounds a bit more exciting, but also riskier, like venturing down a dark alley hoping it leads to a hidden treasure. What if it just dead ends?
Exactly. And then there's a search, which is kind of a rock star in the world of algorithms. It uses heuristics, those are like educated guesses, to guide the search towards the most promising paths.
So instead of just wandering around blindly, it's like having a local giving you insider tips on the best route.
That's a great way to put it. But there's a catch. The book emphasizes that all these search algorithms, no matter how clever, can hit a wall. And it's called the combinatorial explosion.
Combinatorial explosion. That sounds explosive.
It is. It's basically what happens when the number of possible paths in the maze grows so insanely huge that even powerful computers struggle to handle it.
Oh, I see. So even with all these fancy search algorithms, AI can still hit its limits.
Absolutely. It's a reminder that AI isn't magic. It's powerful, but still bound by computational limits. And that leads us to another key point the book makes. Even with the best search algorithm, you need a way to represent knowledge so the agent can reason about the world.
Okay, that makes sense.
Yeah.
So how do you teach a machine what a cat is or the concept of love? I mean, how do you even begin to represent that kind of knowledge?
Right. It's like trying to teach a computer to speak a whole new language. And the book delves into how this is done using logic. It introduces propositional logic, which is like a basic grammar for AI. It allows agents to form simple statements about the world.
Propositional logic. So it's like giving the machine a basic vocabulary to form sentences about the world. But wouldn't that be pretty limited? Like, how could you express something complex like all cats are mammals?
You're right, that's where the book levels up to first-order logic. It's a much more expressive language that can represent objects and their properties and relationships. It's like going from simple sentences to writing full-blown novels.
Okay, so first-order logic gives AI a much richer way to represent knowledge about the world. But I have to ask, wouldn't real-world situations throw a wrench into things? I mean, life is full of uncertainty, right?
You're hitting on a crucial point, and the book definitely doesn't shy away from it. That's where probability comes in.
Ah, so now AI needs to become a master of statistics,
Yeah.
like calculating the odds of something happening.
Exactly. And to handle that, they introduced something called Bayesian networks.
Bayesian networks. Okay, I'm all ears. This sounds like we're getting into the really good stuff.
No. They're basically graphical models that let AI represent and reason about uncertain knowledge. Imagine a web of interconnected nodes, each representing a different variable.
So like a giant flow chart with all these different possibilities and connections. I can see how that could be useful for dealing with real-world complexity.
Absolutely. And Bayesian networks are being used everywhere these days, from medical diagnosis to spam filtering to predicting the stock market. They're powerful tools for dealing with uncertainty.
This is incredible stuff. I'm already seeing how these concepts can be applied in so many areas. So we've got our rational agents, our search algorithms, and now these Bayesian networks. What else does the book cover?
Well, one of the most exciting areas is machine learning. And
Excellent.
that's right. It's where things get really
All right,
interesting.
hit me with it.
So the book digs into how machines can actually learn from data. And it's kind of like teaching a kid, but way more complex.
I'm all about analogies, Leanne. I mean, how is teaching a machine like teaching a child?
Okay, well, think about supervised learning. It's like when you show a kid a picture of a cat and say, this is a cat, you're giving the machine labeled examples, helping it learn to recognize patterns.
Okay, so the machine is like a little data sponge soaking up all this labeled information.
Yeah.
What about when you just let kids explore and figure things out on their own? Is there an equivalent for machines?
That's unsupervised learning. It's like giving a kid a bunch of different toys and letting them sort them into groups. The machine has to find patterns in the data without explicit instructions.
So it's like the machine is playing detective, trying to find hidden connections and groupings in the data. Pretty cool. What about when a kid learns by trial and error, like touch a hot stove and learn a valuable lesson?
That's reinforcement learning. The machine learns by trying different actions and seeing what works best. It's like a video game where you get points for good moves and penalties for bad ones.
Ah, so the machine is all about maximizing its score, just like a gamer going for the high score. It's amazing how all these different approaches to learning can be applied to machines.
Right. And the book talks about how machine learning is being used to do some pretty incredible things, from predicting disease outbreaks to composing music.
That's mind-blowing. It really feels like we're on the cusp of something huge with AI. But I have to admit, I'm still a little fuzzy on the whole rational agent thing. Could you unpack that a bit more?
Sure. The book really emphasizes this concept of rational agents as the foundation of AI. Remember, it's all about making optimal decisions to achieve a goal.
Okay, optimal decisions, got it.
Mm.
But wouldn't a rational agent sometimes make mistakes, especially when dealing with unpredictable situations?
That's a great question. And you're right, in the real world, things are rarely perfect. The book talks about how agents have to operate with limited information and often have to make decisions under
So
uncertainty.
it's like playing a game of chess where you can only see half the board. You have to make the best move possible with the information you have, even if it's not perfect.
Exactly. And that's where all those concepts we talked about, search algorithms, knowledge representation, probability, they all come together. A rational agent needs all those tools to navigate the complexities of the real world.
So it's like an intricate dance between logic, data, and the ability to deal with uncertainty. It's making me think about how we as humans make decisions. Do you think these AI agents are actually mimicking human thought processes?
That's a big question. And the book doesn't shy away from those philosophical implications. There's a whole debate about whether AI can truly think like a human or if it's just simulating thought.
I can see how that would be a hot topic. It's like we're blurring the lines between what we consider human and machine.
Absolutely. And as AI becomes more sophisticated, those lines are going to get even blurrier. The book talks about how AI is being used in areas like art and music, which were once considered uniquely human domains.
It's both exciting and a little unnerving, isn't it? To think that machines might be able to create things that we traditionally associate with human creativity.
It definitely raises a lot of questions about the nature of creativity and what it means to be human. But let's not get too sidetracked. There's still so much to explore in this book. Remember how we were talking about how AI handles uncertainty?
Yeah, the whole Bayesian network thing. I'm still trying to wrap my head around that.
Well, I think it might help to think about it like this. Imagine you're trying to figure out if your favorite sports team will win their next game.
Okay, I can relate to that. I'm a diehard insert favorite sports team here fan.
Perfect. So you start thinking about all the factors that could influence the outcome. Player stats, the opponent's strength, even the weather.
Right, right. You're basically weighing all the possibilities, trying to calculate the odds.
Exactly. And that's what a Bayesian network does. It takes all these variables and their relationships into account to come up with a probability, a likelihood of the event happening.
So it's like a sophisticated way of calculating the odds, but instead of just relying on intuition, you're using data and logic to make a more informed prediction.
You got it. And that's why Bayesian networks are so powerful. They allow AI to make decisions, even when there's incomplete information or uncertainty. It's like being able to see through the fog and make the best decision possible.
That's an awesome way to think about it. It's like AI is developing its own intuition, but based on data and logic. It's making me wonder if AI can handle uncertainty so well, can it actually learn to be creative? I
Yep.
mean, isn't a big part of creativity about embracing the unknown and coming up with new ideas?
That's a fantastic question, and it leads us into another fascinating area the book explores, the historical context of AI.
Oh, right. We were going to take a little trip back in time to see how we got to where we are today.
Exactly. And understanding the history of AI can give us some insights into the challenges and breakthroughs that have shaped the field, and maybe even shed some light on where it's headed next.
Okay, I'm ready to fire up the time machine. Where do we start?
Well, one of the earliest challenges in AI research was machine translation. You know the dream of having machines that can automatically translate between languages?
Yeah, I use Google Translate all the time. It's amazing how far it's come. But I imagine the early attempts were pretty rough.
You're telling me one of the classic examples is this story about an early machine translation system. They tried to translate the phrase, the spirit is willing but the flesh is weak, into Russian and back to English.
I'm already sensing this is going to be hilarious what happened.
The output was, the vodka is good but the meat is rotten.
Oh my God, that's priceless. It really highlights how tricky language can be. Right, it's not just about swapping words, it's about understanding the nuances and context.
Exactly, and that's a challenge that AI researchers are still grappling with today. But even with those early setbacks, there were some really important lessons learned, like the importance of understanding the underlying meaning and structure of language.
So even those translation blunders help push the field forward. It's like those fail videos that teach us what not to do. What else did those early pioneers discover?
Well, one of the big turning points was the work of researchers like Minsky and Papert on something called perceptrons.
Perceptrons. Sounds like something out of a sci-fi movie. What are those?
They were early attempts at building artificial neural networks inspired by the structure of the human brain.
Wow. So they were already trying to mimic the brain back then. That's pretty ambitious.
It was, but at the time the technology wasn't quite there yet. Perceptrons had some limitations, and their work actually led to a bit of a winter in AI research.
A winter, like a period where things just froze up.
Yeah, funding dried up, and there was a lot of skepticism about whether AI could really deliver on its promises.
So even a field as hot as AI has its ups and downs. It's a good reminder that progress isn't always linear.
Exactly. But those periods of doubt and reflection often lead to new insights and breakthroughs. And in the case of AI, the winter eventually thawed, leading to a resurgence of research and the incredible advancements we're seeing today.
It's like a phoenix rising from the ashes. So what were some of the key debates that shaped the field in those early days?
One of the big ones was the clash between the declarative and procedural approaches to AI.
Okay, those sound like two very different philosophies. Could you break those down for me?
The declarative approach was all about representing knowledge in a logical form, kind of like what we were talking about with propositional and first-order logic. It was about giving the machine a set of rules and letting it figure things out.
So it's like giving the machine a rule book and saying, okay, go solve this problem using these guidelines.
Exactly. while the procedural approach was more about defining step-by-step procedures for the machine to follow.
So it's like giving the machine a detailed recipe and saying, follow these instructions precisely.
That's a great way to put it. And these two approaches led to different ways of building AI systems. The declarative approach was more focused on reasoning and logic, while the procedural approach was more about problem solving and task completion.
It's fascinating how these different schools of thought emerged in the early days of AI. It's like they were trying to crack the code of intelligence from different angles.
Absolutely. And those early debates continue to influence the field today. In fact, many modern AI systems blend elements of both approaches.
So it's not a case of one being right and the other being wrong. It's more about finding the right balance for the specific problem you're trying to solve.
Exactly. And that's one of the key takeaways from the book. AI is a constantly evolving field, and there's no one-size-fits-all solution. It's about understanding the different tools and techniques available and applying them creatively to build intelligent systems that can solve real-world problems.
I love that. It's like AI is a giant toolbox, and the best AI researchers are like master craftspeople, knowing which tools to use for each job.
That's a perfect analogy. Now let's shift gears a bit and talk about one of the most powerful tools in the AI toolbox, machine learning.
Ooh, yeah. We were just starting to get into that. I'm eager to hear more about how machines can learn from data.
It's one of the most exciting areas of AI, and it's what's driving a lot of the recent breakthroughs we're seeing.
Okay, I'm ready to dive back into the world of machine learning.
Well, one of the key things to understand about machine learning is that it's not about explicitly programming a machine to do everything. It's about giving the machine the ability to learn from data and improve its performance over time.
So instead of giving it a step-by-step instruction manual, we're giving it a set of data and saying, figure it out.
Exactly. And there are different ways of doing this depending on the type of problem you're trying to solve. One common approach is supervised learning.
Yeah, supervised learning.
Supervised learning. Okay,
Right.
so remind me again how that works. It's like giving the machine a set of data with all the answers already, right?
Right, you give it labeled data. Like, imagine you're teaching a computer to recognize different types of fruit. You'd show it a bunch of pictures of apples, oranges, bananas, and you label each one apple, orange, banana.
Okay.
And the machine, it picked up on the patterns and features that distinguish an apple from an orange, and so on.
So it's like training a spam filter. You give it examples of spam and not spam emails, and it learns to tell the difference.
That's pretty neat.
Yeah.
What about the other types of learning, like unsupervised learning?
Right. Unsupervised learning is where you don't give the machine any labels. It's more like, here's a ton of data, see what you can find.
Okay, so it has to figure things out on its own.
Exactly.
That sounds way harder.
It can be, but it's super powerful, like recommendation systems. You know how Netflix suggests movies you might like based on what you've watched before?
Yeah.
That's unsupervised learning doing its thing.
So it's like it knows my taste in movies better than I do.
Yeah.
Pretty creepy, actually. What about that reinforcement learning thing? The one where the machine learns by trial and error.
Oh, yeah. Reinforcement learning. That's a fun one. It's all about rewards and penalties. Think of it like training a dog. You give the dog a treat when it does something good, and you scold it when it does something bad.
Right.
The dog learns to connect certain actions with good or bad outcomes.
So in reinforcement learning, the machine is like a dog trying to get as many treats as possible.
Uh-huh. Pretty much.
Yeah, it's a good way to put it.
One cool example is in game playing. Reinforcement learning has been used to create AI that can beat human champions at games like Go and chess.
Really?
Yeah. The AI learns by playing millions of games against itself and gets better each time.
That's wild. It's like the machine is its own coach, constantly analyzing and improving its strategy. It makes you wonder what other human skills machines might be able to pick up with this kind of learning.
Right. It really pushes the boundaries. And the book, it actually touches on some of the big implications of AI. Like it talks about AI being used in art and music, which used to be considered like purely human things.
It's definitely a little freaky to think about machines doing creative stuff. Makes you wonder what it even means to be human anymore.
Definitely raises some big questions.
It's like the line between human and machine is getting blurrier and blurrier.
Exactly. But it's important to remember AI is a tool. It's up to us how we use it. We have to make sure it's used for good.
That's a good point. It's like any powerful technology. It can do amazing things, or it can be used in harmful ways. We need to be careful and thoughtful about AI.
Exactly. And the book emphasizes this too. It talks about designing AI systems that are ethical and fair and transparent.
That makes sense. Well, this has been an amazing journey into the world of AI. I feel like I've learned so much. from rational agents to machine learning to all the big philosophical questions.
It's a mind-bending topic for sure.
It really is. And this book, Artificial Intelligence, A Modern Approach, it's been a great guide. It shows us just how powerful and transformative AI can be. And to our listeners out there, I encourage you to check out this book if you want to learn more.
It's a great resource for anyone interested in AI.
Yeah, it really is. Keep those minds curious, everyone.
Absolutely.
Until next time.